Thank you everyone for joining us today. This webinar is part of the GIS Day events, which are happening around the world today. And Simularity has offered to participate by giving a little overview of some interesting discoveries that we've made with our core technology, AIADs, and I'll get into that shortly. And we also have space available in the webinar for questions and answers. And before we get started, I just wanted to go over a couple of housekeeping items. This webinar will be recorded, and all participants will get a link to the recording approximately 2 hours after the webinar is complete. And if you have any questions at all, you're welcome to put them in the chat, which you should see over on the right-hand side of your screen. Or down below, if you scroll down the main window, you'll see a place where you can ask questions, and those questions will appear to us, and we'll be able to answer those after we've gone through our presentation. And with me today, I have Liz Durr, our CEO of Simularity. There she is, waving.
Hello.
And we also have Jean-Marc Montmassin, who is our executive account manager. And we're covering things here from sort of three parts of the continent. Liz is in Tampa, Jean-Marc is in the Bay Area, and I'm up in the west coast of British Columbia. And we've got some really interesting topics today to cover. We wanted to give a very brief overview of our core technology, and then we'll get into some interesting case studies. I'm going to talk about how we used AI to discover some serious deforestation happening in Romania, and that was part of a blog post we did in April of this year as part of Earth Day. And then Jean-Marc will be showing how we discovered some interesting anomalies that you might not have expected early on in the COVID epidemic in the San Francisco airport. And we've got some cool images to show there. And then Liz will be giving a brief presentation on some interesting findings based on our recently launched project regarding the South China Sea and how we're providing alerts in that area. And as I mentioned earlier, we'll have time for questions and answers. You can ask us any questions you want. And we also have a prize to give out that was donated by Esri. We have a one user license to ArcGIS, value $100, and we'll be randomly giving that out to one of you who have decided to join us today. So that will be at the end of the webinar. So with all that said, I'm going to get into the first topic, which is the deforestation case study. And before I do that, I wanted to give a very brief overview of our core technology, which is AIADs, which stands for Automated Image Anomaly Detection System. So in most change detection tools today, they're used by analysts to look at sort of the two different images, and they're typically used so that analysts can find what's changed. And the problem with the change detection tools of today is that they show you all the changes between the two images. And a lot of times there's changes that are kind of normal changes, and there's other changes which are the more interesting or unusual or significant changes, which is what the analysts typically want to see. So the good thing about the change detection tools is that they compare two images, they show you all the changes, but the bad aspect of that is that you see all the changes, and often there's a lot of sort of normal changes that need to be kind of filtered out. So what Simularity has developed is some core technology which takes a look at historical images, and I have an example here in the slide where we've got 5 historical images, and then the most, 5 images, 4 historicals, and 1 candidate image here. And what our software does is it uses artificial intelligence to analyze the historical images, build a model of understanding of how those pixels behave over time, and then compare that model against the candidate image to produce a heat map that shows with varying sort of scores or anomaly scores, and that's represented in color, the significant changes, and it masks out the sort of common or normal changes that are happening, like vegetation coming and going, cars on the road, could be even shadows that are sort of moving around. And this helps the analyst very quickly identify the key areas that they want to home in on. It uses this historical imagery to do that, and the real benefit here is a time saving, because as a lot of us know, there are satellites going up almost on a daily basis, whereas there are gigabytes and gigabytes of imagery that analysts have to pore over, and our software is meant to help them do that a lot more quickly and efficiently. So that I just gave you kind of like a crash course in change detection and how we make it better and faster. So now I'm going to talk about how we used our technology to detect deforestation in Romania from space. And I'm just going to share my screen here so that you can see what I'm talking about. Just give me 1 second here, and I will share my screen. And where I am now is on our Simularity.com website. And if you go there, you will see the link to our blog. And we have various postings there, press releases, partner announcements, and so on. And about 6 items back, there's a post that we made here on Earth Day regarding deforestation in Romania. So you're welcome to visit that at any time. You can do it now or do it later. If you visit our blog post, you'll see that it's fairly short. And that's because we published our main findings and our main case study in cooperation with Up42, which is a geospatial analytics platform that we've partnered with. And so you'll find the link there to the main blog post on the Up42 website. And what this is a nice step-by-step walkthrough which reveals what's happening in some of the old forest growth areas in Romania and how we used RAI. And you can follow that step-by-step even on the Up42 platform, how we use the AI to detect some significant changes happening in the forest. And so this blog post will walk you through how that's done. There are sort of 2 kinds of blocks on Up42. There's like data blocks or imagery, and then there are blocks of algorithms, and we have a few of our algorithms on that platform. And this blog post shows how you can easily configure a workflow made up of image blocks and our processing block, which is AIADs, to execute that on their platform and view the results. I'm not going to go through that whole process now, but just to show you typically how it's done, you would have a job on Up42 and you would specify your AOI or your area of interest. And there are some parameters such as how many images you want to look at. And as I mentioned earlier, you want to have some historical images. So here I used a number of 6. So there'd be like 5 historical images and 1 candidate image to analyze. The results of the job can be downloaded. And I'm now going to show you, since it's GIS Day, a popular GIS that we like to use is QGIS. And I'm going to just switch over to using QGIS where I've downloaded these images. So can you see my screen now in QGIS? Hello?
Yes.
Okay. So what you're seeing now is the output of a sort of a classic change detection tool. So this is what we're trying to improve. As you can see, there's a lot of anomalies here because the typical change detection tools just use really 2 images and show you all the differences between them. Where we come along is we use the historical images to build that model. And you can see here, our anomaly image is a lot less busy, and there's a lot more transparent pixels. And the transparent pixels are where our AI has concluded that there's nothing really unusual here. And where you still see some red, for example, in this area here where I'm moving my mouse, that's still being flagged as an anomaly. And typically at this point, the user wants to know, well, what is it? What's happening here? What's going on? Why has Simularity's technology pointed this out? And what you can do is turn that layer off in your GIS. So I'm going to turn that anomaly layer off. And you can see there's an area here where there has been some, looks like bare soil. And if I turn off the candidate image, which was taken last year at the end of June, you can see there was forestry there. And that was as of end of March 2019. So in 3 months, somebody came along and cut down all the trees that were there. And what also is interesting is that if you remember when I showed the sort of the old school anomaly or change detection image, there was a lot of red up here. And that was because there was snow that had sort of come and gone. And our software doesn't get too concerned about that. There's a bit of an anomaly image there, but it's nothing like what the change detection tool gave. So that's the beauty of AIADS. It filters out some of these sort of normal changes like snow coming and going and helps you lock in on more significant changes such as that clear cutting that happened here in this area. So that's what I wanted to show as far as a case study of how you can use AIADS to find these anomalies. And now I'm going to hand it over to Jean-Marc.
All right, thank you so much, Peter. All right, I only have 2 slides or 3 slides I want to share with you, but what's really interesting is how our technology has been deployed on a very different use case than detecting clearings in forest or jungle and so on. And this has to do with the financial industry. And what we were able to do using our algorithms and AI is to detect early on leading indicators of COVID-19 impact on, in this case, the rental car industry. If we move on to the next slide, I'm going to show you exactly with images what happened. So one of the things that I don't know if you picked up on is our software, really the power of our software is to track and monitor very, very large areas. And as such, what we did is we were monitoring all of California. And within all of California, we detected unusual anomalies in Northern California, specifically around the San Francisco airport. And within the San Francisco airport, specifically around the rental car buildings, parking lots, and also long-term parking. And so what's interesting here is automatically we looked at a whole state and really then focused on a very specific area, not even all of the airport, but a portion of the airport. If we move on to the next slide, I'll show you exactly what happened. So first of all, let me kind of explain a little bit the layout of that section that we're looking at. In green, where it says rental car facilities, so that green overlay is the parking lot for the rental cars and also the building. So if you ever fly into SFO and rent a car, you'll take a small train and it'll take you to that building where you're going to pick up your car, and that's also where you return it. Around there in blue is the long-term parking. If you live in the Bay Area and don't want to take a Uber or a taxi, you'll drive your car, you will park in one of these, and you're going for a long-term trip, you'll park in one of these open air parking lots. What's also interesting is that the top north part here of the blue rectangle where it says rooftop parking, that is actually a 5-story building, which is also all long-term parking. If you now look on the right, and right, obviously the image on the left is from March 4th this year, and the image on the right is from April 1st. So this is really pre-COVID, post-COVID lockdown here in the US. What you see here is that our AI was able to detect abnormal activity happening around the green portion, that's the rental car facilities, because more and more cars were being stored because they weren't rented. And that's expected. But the big leading indicator here was the rental car companies did not have enough space, so they had to go in and store the cars atop the rooftop parking there at the top north, rental cars. And the reason we're able to know that is because it was highlighted, as you can see in red, with our AI, and we know that basically all the long-term parking at this point are empty, as you can see on the picture. What's also interesting is you can see that the long-term parking was not flagged as an anomaly. It's because cars are coming in and coming out, and we track that as normal behavior. Now, when there hasn't been cars on the rooftop parking for a while, that will be tracked as a flag. So as you can see in a very simple example, we went from looking at a whole state, monitoring a whole state, to narrow down on a very small portion of an airport to detect a leading indicator. As you know, Hertz was in somewhat bankruptcy filings or close to that a few months later. So this was potentially a leading indicator of how the rental car industry was going to do. Thank you.
Awesome, Jean-Marc. So once again, if there's any questions, people feel free to scroll down from the slides there. You'll see an area where you can send in questions, or you can put them in the chat. And I'm now going to hand it over to Liz Durr, our CEO, to talk about the South China Sea Service Alert Service and some interesting discoveries she's found there.
So we recently launched our South China Sea Rapid Alert Service, and what we're able to do with our AI is monitor vast areas, like as big as the South China Sea, which I believe is 3.5 million square kilometers, and use our AI to automatically look through all that imagery to find anomalies that might be indicative of some bad behavior. It's a hotspot, a global hotspot right now, and we want everybody in the world to be able to see what's going on and have that transparency. So what I'm going to show here is looking for suspicious ship behavior in the South China Sea. We've shown you two examples of finding anomalies on land, and a lot of the action that happens in the South China Sea is also on the sea. So the data sources that I used in this, one is AIS. It's the Automated Identification System, and that data is broadcast by large ships. In fact, if the ship is more than 30 feet long, it's required to broadcast this data. The data includes the Maritime Mobile Service Identity, or MIMSI, which is a unique identifier for that ship. And you can kind of think of it like a cell phone number, where the AIS unit is the cell phone and the AIS unit is on the ship and broadcasts periodically and sends the latitude and longitude of the ship, as well as the date stamp for that measurement. Another thing that we've got to track ships on the South China Sea is VIIRS. It's Visible Infrared Imaging Radiometer Suite from NOAA. And what it is able to do is pick up bright lights at night on the water. And frequently, illegal fishing is done at night, and they use bright lights to attract the fish to the top of the water and scoop them up. Often, the people doing illegal fishing do not have their AIS turned on because they don't want anybody to find them. And finally, we have optical and SAR data that we're able to use to find ships. But both of those only are taken periodically. So you've got the satellites coming around and taking pictures. And in the case of the optical data that we're using, it's about every 10 days. So there's a lot that could happen in there. So we need a variety of data sources to find these ships and understand what they're doing. The type of suspicious behavior that we're looking for, all of these are anomalies. They're anomalous activities, and that's how come they can stand out and we can find them. Smuggling of oil, drugs, and people, illegal and unreported fishing, dredging, replication, and artificial island building, which does great harm to the ecological system and the fisheries there. Aggression and incursion into the exclusive economic zones of the countries that border the South China Sea. So the first example I want to show you happened in February, and I'm showing examples from February because that's the AIS data I got that was supplied by Spire to us. And it happened just 4.7 nautical miles from an island in the Philippines, you can see on the map here. When you look at the MMSI, the MMSI for this ship, you can then go and look it up on websites and find out exactly what it is. In this case, it's a bulk carrier, like a cargo ship, belongs to China, and actually had 4 name changes in the last 2 years, which is a bit suspicious in and of itself. It's a very large ship, and you cannot fish off of a ship like this. So we know that ship wasn't there doing fishing. What we found it doing, and the reason we found it, was this anomalous behavior that you can see here. There's a normal path with this straight line here that of ships that go through this area. There's shipping lanes and ships go through this area on this path quite frequently. We saw this activity outside of that normal path and a whole cluster activity here. When you look in on that, you see this ship sailing around for more than 8 days in that tiny little location. There's no good explanation for why a bulk carrier ship would be doing that. And we can see its departure path on February 24th, where that also is not in line with the normal shipping lanes in that area. So this is all the AIS ship data in this specific area of interest for February 16th to 24th. Because we only have the AIS data for this period of time and this limited area, there are a number of things we don't know yet. One is where that ship came from, because on February 16th, it was already there. 2 is how long it was there, since we don't know when it arrived. And 3 is where it was going, because its path took it out of our area of interest. So AIS data can be super useful and interesting, but like a lot of our search for information and truth in what's happening with the GIS data, you always want more. And this data is not inexpensive, so we are looking at expanding our AIS data. The yellow dots represent AIS data. The blue dots down here represent the bright lights at night detected by the VIIRS. And those are on the water and nearly guaranteed to be fishing. And you'll notice that very few of the blue dots line up with the yellow dots, meaning those fishing boats are generally not doing things they're supposed to do if they turn off their AIS. They could be small fishing boats, but they would have to have really bright lights on them to be able to show up at night here, which is not, a little 2-person fishing boat. So that's a good indicator that there's some illegal fishing going on right there. My second example is of aggression and incursion. And this happened on T2 Reef, which is near T2 Island. You can kind of see it over here. It's a member of the Spratly Island group. And it is right next to Subi Reef, which is an artificial island that is occupied by China, and just 9 nautical miles from T2 Reef, which is called Pagasa Reef by the Filipinos. In the chart down here, T2 Island is on one portion of the reef, and we see suspicious activity by Chinese ships over here in this other part of the reef. What they're doing there is most likely preventing the fishermen on T2 Island to actually fish, and also preventing supply ships to come and resupply the civilians living on T2 Island. So here, discovered by our anomaly detection, are ships in this corner of T2 Reef. And when you look at them in the satellite image here, some of them look like normal shaped ships, but some of them look kind of square or even rectangular. And that's a little strange until you realize that the Chinese frequently moor long lines of expensive shipping vessels and fishing vessels in a row. So when you look at more detailed satellite imagery, you can see what they're actually doing, and you can see why that would show up as a square rectangular shape on the 10-meter satellite imagery. That imagery is provided by Sentinel-2, the European Space Agency. This imagery here was from 2018, to give an example, and they've been at this for quite a while to some degree or another in putting these ships here. So in looking at this year and the ship activity at T2 Reef, the red line indicates ships that we were able to count using the Sentinel-2 imagery. And as we got imagery, we were able to count the ships in the imagery there as identified by our AIADs, and report that there was a peak in February, and then it seemed to calm down through the summer. But towards the fall, the peak started rising again. We have a partnership with a GeoInt analysis group called AllSource, and they have access to synthetic aperture radar, which they were able to use to enhance our ship counts. So frequently, as I said, we get images every 10 days or so. In between that, we don't really have a view as to what's going on optically, but these ships do show up on radar, and they were helping us with the count, and that's that blue line here. So you definitely see a spike happening in the fall. So this is a summary of the analysis that AllSource and I put together, trying to confirm where we believe these ships are from and that they are Chinese ships. None of them have their AIS turned on, so we can't tell from the MIMSI that they're Chinese ships. But looking at this data, we identified about 20 vessels. We did find a MIMSI on one of them that was Chinese. And the backscatter return from the radar on some of these vessels, understanding that they've been doing this for several years off and on. The idea that occupants have seen Chinese fishing boats doing this before, we believe that this is nearly certain that these are Chinese ships that are continuing to block the fishing and the resupplies to the Filipino occupants of T2 Island. So that's all I've got. It's an interesting way to use a lot of different types of GIS data to solve some mysteries and find some bad actors and try to put a stop to some of the illegal activities that are going on. When you're trying to stop illegal activities that people are trying to hide, you have to use as many tools in your toolbox as you can. And that's why we're using a variety of data sources to do this analysis.
That's great, Liz. Thanks a lot. And where can people go if they're interested in signing up for the free level of the South China Sea service, Rapid Alert Service?
Right. So if you go to our website on Simularity.com, there's a link to sign up for this South China Sea Rapid Alert Service, and you'll get GeoInt reports like this. As soon as they're available, we are monitoring the area continuously, and the service is free. We're doing this free because we believe the world needs to know what's going on, and we want to shine a light on that, and also to demonstrate the power of our technology. Thank you.
Excellent. Thanks, Liz. That's great. So that wraps it up for our three main topics. And I'll open it up if anybody would like to ask questions. They're more than welcome to. I don't have any questions posted here, but I know that some people may have questions afterwards, so they're welcome to contact us through the website. We have a chat widget on there and also a contact form, so you're welcome to reach out to Simularity at any time and let us know how we can help you. And also for the prizes, while Liz was talking there near the end, I did do a random draw for the ArcGIS license. And the winner of the license is Sanjeev Gupta. So Sanjeev, just get in touch with me. I have your email actually, so I'll be following up with you to get that license to you. And congratulations on that. And thanks for joining us. And once again, for anyone who wants a replay of this, they will be getting an email automatically from the webinar platform that you registered with here. It'll come in a couple hours, and we'll also be posting it on our website as well for anyone else to access. So thanks again, everyone, for participating today for our GIS Day event. And we hope to have more webinars in the future, and hope you can keep in touch with Simularity. Thank you very much, and have a great day.
Thank
Bye.
you.